Welcome to the first lecture of the course of maintenance. In this lecture, we will test your understanding of the fundamental concepts of maintenance. Let's get ready for a fun journey. Well, the first thing that I would like to show is the table of contents for today. So we have 6 topics, and the first one is, why is maintenance important? Okay, let's start with this question. This is a valid question in aeronautics. There are not many accidents in aeronautics, hopefully. And we could think that maintenance is a very well-established field because of this, that there is nothing more to investigate. But is it so? According to IATA's report of 2022, the results are quite different. The IATA is the International Air Transport Association. Okay, so let's see what the report says. In 2022, we had 39 total accidents in commercial aviation, compared to the 29 accidents in 2021. And the number of accidents per flight is also low. What is an accident in IATA's terms? Well, this is a criteria here that should all be met to be considered an accident. And we have here the reasons, the causes of most accidents, starting with weather condition, aircraft malfunction, and others. If we look at the 4 reasons that I'm selecting here in black, we can see that maintenance is actually responsible for a huge percentage of the accidents, actually. The thing is, maintenance is very related to safety. And to ensure safety, we need to guarantee a proper maintenance of our aircraft. Maintenance is vital for safety, and every single accident that we can prevent is worth trying. The economical value of maintenance is also of relevance and important. Every year the numbers change, but it's about 10% to 15% the contribution of maintenance to the total costs. It is relevant. It's not a very big number, but it's relevant considering that the airline profit margins are very small. And remember that we are talking about millions here. So it's still relevant and still significant. Another thing that might convince you of the importance of maintenance is customer service. When you are a passenger and you're waiting for an airplane, if you encounter a situation such as a delay or an airplane on the ground event, it is very disturbing for you. So this is another reason why maintenance is important. Some companies for these situations find extra aircraft, but the problem here, and as you can guess, is that there are extra costs involved in this. So to finalize, let us do a small exercise. Imagine that you have an engine, and the engine is not performing very well due to lack of proper maintenance. What do you have? You have more wasting of fuel and more pollution created. These are 2 problems that relate to sustainability, and as you know, sustainability is a goal that we all should care about. Now let us see 3 lessons about maintenance. There are several myths or misconceptions about maintenance, about what happens in maintenance. And one of these is the lack of awareness about how digital and how advanced in terms of technology the world of maintenance is. If you think it's an old school field, you'd be surprised in reality by looking at how we are using RFIDs, drones, robots, and advanced algorithms such as neural networks and artificial intelligence to make maintenance work in the best possible shape for aeronautics. So let us debug 3 myths related to this. The first one is that it relates to things failing. Some people think that things cannot fail. That's not the totally true. Catastrophic malfunction rarely occurs. That's true, but there are what we call incidents. Okay, not accidents per se, but incidents, which are small situations of that impact safety. One such incident was reported in this news by Sky Library, and the news details a smoke incident due to the engine bleed system failure. Okay? Unfortunately, this was not an isolated event. There were 500 incidents reported for the A320 in the same year as this. So that you have a notion, even engines, which are critical systems, can go through unscheduled maintenance interventions. So this highlights the need for continuous monitoring and proper maintenance at all times. The second myth is that we do not do cutting-edge technology in maintenance, that we still stick to old technology, old formulas, old things. This is not true, and I want to talk about the specific case, which is the Airbus Hangar of the Future. Airbus created the Hangar of the Future project with the aim to revolutionize, to give new ideas to the sector of maintenance. And it's basically a laboratory where you apply lean management techniques and other techniques of relevance, such as robots, drones, virtual reality, artificial intelligence, and so on. And the good thing is that this project has a real-world application and a real-world impact. Okay, this is just an example of how we actually do cutting-edge technology in maintenance. The third myth has to do with failure. You may think that failure is a simple phenomenon that is very easy to figure out when something is broken or it's about to break, but it's not so easy. The failure is a complex phenomenon, and it takes time to understand it. And you have to always monitor several signals to figure out if something bad is going to happen. So it's complex, it's difficult, it takes time, but it's indeed possible. An example that I like to give is that of a doctor who has real-time information about the health status of its patients, and the doctor with this information can diagnose and prevent diseases and do it ahead of time. It is something that we take for granted, but in reality it's astonishing how aircraft can fly for decades and stay in service for decades. And maintenance is a great responsible for this. If we did not have maintenance, most likely we wouldn't have the same performance. Even though predictive maintenance is gaining traction in the field, we must not forget that a great responsible for having great performance is scheduled maintenance. So we will see here the alphabet of aircraft maintenance. A concept that I would like to talk about is hard time events. These are checkpoints that represent rigid limits on which the scheduled maintenance must occur. They can be expressed in calendar time, so hours. Hours, it's a bit too much, but maybe months, years, and so on, or in usage time. Okay, so cycle time, number of flights that the aircraft or missions that the aircraft has done. And so you can imagine a clock ticking or a flight counter spinning, it depends. And once it reaches the value, the maintenance hard time checks have to happen. So aircraft is a hard time component because it has hard time events that we call checks. The aircraft goes through checks, okay? It has 4 major checks, A, B, C, D. And you can see that the A and the B checks are light checks, and the C and D are heavy checks, and the intermediate layover is an intermediate check between the C and the D check. So let's see each of these checks in detail. So let's start with the A check. This is a check that occurs bi-monthly or monthly. It always occurs in the hangar, so we're not talking about line maintenance for any of these checks, by the way. And it occurs at the 500 to 800 flight hours or at the 200, 400 cycles. Whatever happens first, either the limit of flight hours or cycles, then you do the maintenance, the check. The check consists in a general inspection, both of the interior and the exterior of the aircraft. It takes about 6 to 24 hours in a narrow-body aircraft, so it's a relatively quick check. You can see it as a quick visit, like metaphorically giving a high five to the plane before it takes off to its next mission. Then we have the B checks. The B checks are becoming more and more phased out by some airlines at least. And the strategy or the idea is that if you do more frequent and more light checks, then you are more effective in your maintenance interventions. Finally, we have the C check, which is in which we are entering heavy maintenance. It occurs every 12 to 20 months, so it doesn't occur that frequently as the A check. And it is extensive. It involves an extensive inspection of the aircraft, including a little bit of structural damage inspection. Tasks that are involved are, for example, system checks, cleaning, and servicing. The intermediate layover is a check between the C and the D. Some airlines do not consider this check, but others consider. And the thing it does is a light structural maintenance. So it doesn't do the heavy structural maintenance of the D check, but it's a bit more than the C check. Okay? And the tasks involved are inspections, checks for corrosion, high-load parts are inspected, and other tasks are also done in this type of check. Finally comes the last check, which is the D check. This is the heaviest intervention and the most comprehensive intervention of maintenance to aircrafts. It happens every 6 to 12 years. It lasts several weeks, and several things happen during this check, such as the paint is stripped, the outer panels are removed, all of this mainly for doing a better structural inspection, because this is the moment when a very major structural inspection happens, more than even in the C check or the intermediate layover. Okay? Importantly, the internal components are also checked and serviced. And you can see this as a training camp for the plane. Well, every inch is scrutinized, and the goal is to make the plane more resilient. Let us now talk about the topic overhaul of an engine. First of all, what is an overhaul? Well, the concept is more or less straightforward, and it's usually related with words such as to fix, to improve, to modernize, to rebuild, to reorganize, and to re-examine. The idea is that you tear down your system and according to the manufacturing specifications, and you make it go to a tip-top shape again. But there's a difference between repair and overhaul, and one is different from the other. A repair is to fix something that was considered broken or malfunctioning. It's what we call a targeted action for a specific system or component. In turn, an overhaul is a more extensive action that involves sub-actions and that goes beyond repair. It includes, for example, the disassembly, the cleaning, the repairing, and the reassembling of the system. The idea is that you receive the system, you make an overhaul, and you make it go into a good as new condition with optimal performance. We know that this does not always happen. We do not always have optimal performance, but the idea is to get as close as possible to that strategy. We can adopt the following definition shown here that was agreed between FAA and EASA for overhaul. We are talking about overhaul, and this is a very common thing that we're going to talk about in these classes. But beyond aviation, overhaul can also be applied to car engines and also to marine engines. In KLM website, you can find a specification in 5 steps for an engine overhaul. They explain how they do the engine overhaul in 5 steps. And the first step starts when the engine arrives at the maintenance facilities of KLM. And this can happen due to the calendar time or due to the usage time, like in the case of the aircraft. So every 5,000 flight hours or 3,000 flight cycles around this value, they say the engine is overhauled. But to do so, you also need to make sure that you have the work scope in place, which is basically just a to-do list of the things that you need to do when the engine is overhauled. Now let us see step 2. Step 2 involves the washing of the engine. This means that the engine goes through several baths using different liquids so that you can scrub the dirt away and the dust away in the best possible manner. After this, the engine is ready for a visual inspection, either using cameras or manual inspection. The step 3 involves the disassembly of the engine. So we have this complex puzzle of around 40,000 pieces because the engine is very complex and it's an intricate machine. And we have to break it into pieces to tear it down. After that, you will send the pieces either to KLM repair shops or to a supplier that is responsible for taking care of the system. The step 4 is the repair and the replacement of the parts that have problems. And finally, the step 5 is to put the puzzle pieces back together. So after you reassemble the system, you can test it. You can send it to the test cell where it undergoes rigorously testing. And after that, there is a team of inspectors that will issue a certificate of airworthiness if everything runs okay. Are you curious to know who are the stakeholders of aircraft maintenance? Well, let's talk about it. There are several organizations involved in aircraft maintenance, and we will talk about their roles and contributions, starting with airlines. Airlines, also called by operators, are perhaps the central organizations in aviation because they own and operate aircraft. So they are like the clients of the industry. But we also have military customers, and they have special needs because every flight is a distant mission, subject to different degradations. So the maintenance is also different for these clients. We also have the original equipment manufacturers, which build aircraft for end users, which in this case, they are the airlines. There is a considerable number of airlines operating at a global scale. An example of an OEM is Embraer Brazil, for example, who provides, constructs, builds commercial but also executive jets. So finally, the suppliers, they are organized into a pyramid, a shape of a pyramid. They are organized into tiers, and the tier 1 supplies the OEM, while the tier 2 supplies the tier 1, and so forth. The maintenance, repair, and operations are specialized companies, and basically what they give is maintenance services to the different stakeholders. They can be either independent service providers or be part of an airline or a manufacturer. Talking about regulators, they are responsible for establishing but also imposing the law, making sure that everyone is accountable for their actions in the aviation industry. There are several regulators, such as the Federal Aviation Administration, or the European Aviation Safety Agency, or even the International Civil Aviation Organization, who operates on a global level. And finally, we have the airports, who help perform line maintenance. And this is for us the last of the organizations that we will review. We now will talk about failure and maintenance and how to define them. Finally, let's talk about some concepts. The first concept is the concept of performance requirements, which is basically to say that you need a criterion for a certain functionability. So if you have a function, to say that that function is respected or not, you need to set a criteria. So basically, a list of performance requirements are just a functionability checklist. So to see if everything is running according to what you have defined. Another concept that is interrelated with performance requirement is that of operating condition. The operating conditions are nothing more than the environment to which the system is exposed. So everything like temperature, wind, flight stages, anything that can change the signals but are not related to degradation are operating conditions. And finally, let's define the concept of maintenance, given the concepts that we have discussed, the performance requirements, and the operating conditions. So, important to say is that maintenance is a continuous process, so it doesn't happen just when there's a failure, and it involves a balance between costs and benefits. Finally, it is important to talk about the concept of failure, which is the state of condition of not meeting a desired function. So this interrelates also with failure mechanisms and failure mode, which means that a failure mechanism precedes a failure mode and is usually in a more reduced number than failure modes. So a failure mechanism happens and then one or more failure modes can occur. By the time of the end of this lesson, you should be able to list, define, and distinguish fundamental concepts of maintenance. And I wish you safe travels and blue skies ahead.